Hello, ELT 132. This is Roger Young, and we are going to talk today about some more Boolean algebra. I'm sure that's one of your favorite topics to discuss. So, what I'm going to do here is get my pencil all set up, right? You want that? I want probably that. There we go. So here are two Boolean expressions, right? And let's just go over how you would go about solving these, right? So this one, let's do the top one first, obviously, the second one, bottom, this one second. So we have four terms. I'm sorry, 1, 2, 3, 4. Now listen, right now what I want you to do is pause the video. And I want you to attempt this yourself. And then restart it and then go over the solution. All right? So go ahead and pause it now. All right, everyone, I assume you paused the video and you tried it. And here, let's go over the answers, okay? So let's do this. What's the first thing you think you would want to do here? Let's look at common terms, right? So here we have A naught, B naught, C naught, A naught, B naught, C, right? So what do you think we could do there? If we did this, this is equal to A naught, B naught, right? I just took the A naught, B naught out of both of these first two terms. What are we going to be left with? C naught or C. I didn't say plus, I said or because that's the gate. Now that took care of these two terms. What about these two terms? Well, we could do something else, couldn't we? We could then, there we go, plus A, B, C naught or C. Now, you see these two terms, C naught or C? You have a OR gate, right? Now you have, this is C coming into it, right? C's coming into it, and you have another one which is C naught. What is Y going to equal? And we can answer that by simply drawing the truth table, can't we? If we know we have a 0, 0, 1, 0, 0, 1, 1, 1. Now what's your Y going to be equal to? I usually call these A and B. We'll do that just for the generic truth table. Now what's Y equal to? Well, if it's 0, it's going to be what? 0. But all of these are going to be 1, aren't they? In this case, if this is a 2-input OR gate, it's going to be one of these always, right? Because one input will always be the complement of the other one, which is another way of saying if C is 1, this is 1 right here, then what the other input is going to be 0. Or if this is 0, this input is going to be 1. And here you have both cases, right? So they're both 1. So basically, this goes to 1. And this just goes to 1. So what are you left with? Well, this is A naught, B naught, or A, B. Right? There you go. That's your first one. That was the first one to give it a go on, right? And if you didn't quite get it, don't worry about it. It's practice. The more you do, the better you get, right? Because you have to be able to see these things when you're doing them. Now, I got my notes here. Let's do the next one. So at this time, I want you to pause the video, and I want you to try to solve this one. Now, I want to tell you this one is rather tricky. It's not simple. So I'm going to do this through stages to simplify it. And at any time, if you wish to pause the video, just pause it, and then I just may have to give you something to get started. You can pause it and then try to finish it and then watch it, okay? So go ahead and pause it now and give it a try. Okay, at this point I think you all gave it a try, and let's see what we have now. So what I'm doing here, y is equal to, I'm just going to bring this term down. A plus b, or I did it, didn't I? I said plus. I meant or A or C or B. Or you can say A plus B plus C. It doesn't matter. So let's concentrate on these terms. All right? So better yet, I'm going to treat B naught plus C naught as a single variable. So I'm going to draw that around there like this. That's a parentheses in case you see it. So it's going to be, that's a terrible parentheses. I'll leave it there. I'll leave it there, whatever. So what do we have? We're going to have A bar. That's multiplying A times A bar. And now we're going to do what? We're going to multiply A times B naught plus C naught, right? So this is going to be plus A times B bar plus C bar. That's a bar. I'll put a bar here, all right, just so you can see it, all right? So that was, we took care of this, A multiplied by this one, right? A multiplied by this group, right? Now we have to keep going, don't we? Plus, now we're going to take B bar plus C bar, right? This group we're treating as one variable. We're going to multiply it times A bar, okay? I'm just going to reverse it a little bit. I'm going to call it A bar times B bar plus C bar. Got it? So this took care of this term multiplied by this term. You understand, I'm going to write it over here, that B bar plus C bar, right, times A bar equals, that's equals A bar, it's an A, doggone, my drawing is bad, isn't it? A bar times, I think I forgot a bar here, didn't I? I forgot a bar, sorry about that. So it's B bar plus C bar times A bar is equal to A bar times B bar plus C bar. And that's what I put here, okay? And finally then we have B bar plus C bar, and that's twice, right? Pretty good. All right, there we go. Now, let's think about this. What is this? Isn't that simply, I'm going to write it over here. That's an AND gate, isn't it? And you have A coming in here. That's inverted. If that's A, right? What's Y going to equal? We can answer that by the truth table, right? We have 0, 0, 0, 1, 1, 0, 1, 1, right? And for an AND gate, right? I usually call this A and B for a 2-input gate. This would be 0, 0, 0, 1. In this case, AA bar, it's concentrating on these two center ones again, and in both cases, there's 0. So this one is simply going to go to 0. All right? So let's rewrite this thing here. This is going to equal, see if I can rewrite this better, right? A plus B plus C. All right, that's your first term, right? Bingo. Now let's try your second term, right? So the second term here is going to be A times B bar plus C bar, right? I just brought it down right here, right? All right. Plus A bar times B bar plus C bar, right? You know what? There should be a plus in here. It was my fault. There should be a plus right here. Sorry about that. I wrote that incorrect. There should be a plus right in there. So then you would have a plus, what? B bar plus C bar. And then we're going to have a B bar plus C bar. Sorry about that. That was my mistake. There should be a plus here. I think you already know that, right? Okay. So let's look at the next one. How can we simplify this? Well, this is going to equal this term, A plus B plus C, right? All right. Now, let's try this here. Times, what is a common term we have here? A plus A bar. All right. What do we have here? A bar, and then plus, my fault there, plus C bar, right? All times B bar plus C bar. See, B bar plus C bar is common to all of these terms. I just factored it out. That's all I did. Now, what do you have here? You have A or A bar. We just had a case like that up here. What does that equal? That equals 1, doesn't it? A plus B plus C. Here we go. Now this is going to be 1 plus B bar plus C bar. All right. Now, remember, you have an OR gate and one of them is 1, right? It's simply going to be what the other one is. So here, you can just look at this. I'm sorry, that's your AND gate. Here is your OR gate. So we have an input of 1, don't we? If one of the input is 1, the output's going to be 1, right? So what you can do here is this B plus C. You know what? I think, did I miss something here? y equals a plus b plus c. Okay, that's right here. Okay, no, we're good. We're good. I had to think for a second here. So we know this is going to be bar plus c bar. If this is 1 and it's an OR gate, this is going to go to 1. That's what I was trying to say here. If you look at this OR gate, which is what we have here, if you look at this section right here, see this? A is always 1 here, right? You see A is 1 here, and A is 1 here. When A is 1, when one of your inputs is 1, the output is always 1, isn't it? So here you have an OR gate. This input is 1, so this is actually going to go to 1, isn't it? So then this is going to simplify to A or B or C, right? Times B bar or C bar. Well, that's the final answer. The key is this, folks, when you go through it. You didn't have to multiply this out completely. Come on, let me show you. We combined B bar plus C bar and we used it as a single term. That simplified things. So if you look at what happened, we made that one term and then we multiplied it out, okay? Then we factored out the A's again, so you had A plus A bar plus B bar plus C. These two obviously factored out to be 1, right? Which we know I should probably just draw a line there. This here is equal to 1, right? And if you have 1 ORed with anything, it's going to be 1. And then if you multiply anything times 1, that's what it is. So it's what you multiplied by. So this goes away and you're left with B bar plus C bar. Now I hope this has helped you. Again, the more problems you do, the better you get. So thank you very much, and I will see you soon. Bye-bye.